Alright, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still building the MachOCodeGen, MachOReader class. Yeah, last session we have been wondering how we process a vtable. So we need to figure out two things. We need to figure out which virtual functions override other virtual functions, and what names do pure virtual functions have, which we don't have the names for currently because we don't know the relationship. So yeah, this is interesting. How do we do it? How do we do it? So when I this confuses me. This one here, because all these here override certain update module. So update module is inheriting behavior module and update module interface. Yeah. And update module interface owns these two here, this pure virtual and this one. But then we have this one squeezed in between here. Wait, does it maybe belong to behavior module interface? Behavior module interface. Behavior module. Behavior. Let me see. Behavior module. Behavior module interface. It's not in here. It is. Yeah, but this one, it doesn't have get update phase. It doesn't have it. Update type info time. So okay, behavior module interface. Behavior. Oh my god. Type info for behavior module I can't type. There we go. Oh shit, that's not the right one. That's the right one. Ah shit. They're looking for vtable. Vtable for this. There we go. Oh, it's all pure virtuals. Oh my gosh. That's some bullshit. Oh. Hmm. Okay, how do we do it? So, the virtual destructors, they don't really count. Shit. There must be a rule, but I don't see it right now. Okay, how many are these? Ugh, don't want to count. But it's probably all of these here. All of these. Right. And then we have this one function, get update phase. I find this so confusing, I have to say. Update module. Yeah, it's this one function that I don't understand. Why is this sitting here? Why is this not sitting at the very end or at the very start? No, I think this one, yeah, actually, it should be sitting at the very end, but it is not. And I don't understand why. Yeah. I don't understand why that is. For 10, 14. Snapshot. This one probably refers to snapshots. This one refers to behavior module interface. F0. F0. 10. It's 10, offset 10. And then offset 14. Offset 14. Oh, right. EC, this is. Right. Okay, I understand now these offsets here. EC, yeah. Okay, but I don't think we still need the. Well, actually, virtual thunk. So we have two destructors. Then we have one pure virtual. One pure virtual. Let me ask ChatGPT about this. Okay, so I would just copy this whole thing here. Yeah. Copy. Let's ask here. I have the following vtable in EDR from following MachO vtable in EDR. Well, let's say GCC. I have the following GCC vtable in EDR. All virtual functions are all virtual functions are all virtual functions except update module get update phase void get update phase void are declared in base classes. How is it possible that one new virtual function inside update module sits between other virtual functions between other virtual functions from the base classes. Shouldn't it be at the end? Shouldn't get update phase be at the end? What is the rule? What is the rule? In different base classes. Okay, let's ask ChatGPT. The placement of in the middle of the vtable rather than at the end can be explained by GCC's vtable layout rules, which are based on C++ multiple inheritance and virtual function table ordering. Let's break down why this happens. Primary base first. If update module derived from a base class with a virtual table, it inherits a vtable. The vtable begins with a layout of the primary base class. If update module has other base classes with virtual functions, their methods are appended in the specific order. New virtual functions of update module. Any new virtual functions declared in update module itself are placed where the compiler determines they should be. Well, okay. Where should it be? If a virtual function overrides a base class method, it stays in the same slot. Yeah, to maintain compatibility. If a virtual function does not override a base function, it may be placed after all inherited virtual functions or in an empty slot. That was previously reserved in an empty slot. Is a new virtual function. Normally, new virtual functions are placed at the end of the vtable. However, GCC sometimes fills empty slots left by base class methods where that weren't overridden. Empty slots had a placeholder slot. A base class had a virtual function slot that was left empty. What the fuck? GCC reused that slot when update module introduced get update phase instead of appending it at the end. If a new virtual function in a derived class does not override a base class function, it is usually placed at the end. However, if the vtable has an empty slot left by an unused or removed base function, unused or removed, GCC may place a new function in that slot. If the function overrides a base function, it stays in the original base class slot. If the function is part of a secondary vtable multiple inheritance, it placed after the primary vtable entries. Secondary. The reason it appears in the middle of the vtable rather than at the end is because GCC found an available empty slot. Whoa. Okay, that's confusing. Likely left by an unused virtual function from a base class. An unused virtual function. An unused virtual function. Instead of growing the vtable size, GCC reused that slot to improve memory layout. This behavior is specific to GCC and follows its vtable slot reuse optimizations. Oh. Oof. Oh. Okay, that makes things complicated. Well, if that's the case, then how do we deal with this? I find this really confusing now. I was hoping for an absolutely easily deterministic way, but this thing sounds really complicated. Oh boy. Shit. What are the rules? What are the rules for GCC to reuse an empty or an unused vtable slot? Specific rules. The slot was originally occupied by a base class function that was removed or not used. What does it mean, was removed? If a base class had a virtual function, but the derived class does not override it, the slot may remain empty. Instead of leaving an unused slot in the vtable, GCC may insert a new virtual function there. GCC may place it in an empty slot. The slot belongs to a base class that was optimized out. Okay. Maybe what we can do is we can say if we encounter a function, a virtual function that is not present in any of the base classes, then we shift the index. We shift the index. Yeah, that we could do. That might work. Okay. Okay, I think we also need special rules for the destructor, because we should only override 2 destructors at max, aka the deletion destructor and the non-deletion destructor. How do we program that? Oh, that's shitty, isn't it? vtable entry index. Yeah. Oh, this is a problem because of the pure virtuals. I don't know how to code this. I really don't know how to code this. placed in the same slot. Check for unused vtable slots. Okay, shit. VTable slot. VTable slot. Okay, I think what we also, but I don't know. Let's say here we add another, we add an integer here, int detour the destructor count, okay? Int destructor count. Okay, we say we pass 0 here. And we say base class destructor count. Destructor. That's a problem. What if it has no destructor? Destructor. Destructor. I don't know if this passing here makes sense. Let's remove it again. Vtable entry. How about we say Oof. This is hard. I think what we need to say is if this vtable if out vtable entries if it is not empty, let's say a bool expect destructor, expect destructor, let's put it false. If not vtable is not empty and vtable entry 0, function index is not invalid index, and functions function index dot, oh boy, is ctor or dtor. So if that is the case, then expect destructor is true. Oh boy. And then we say if expect destructor equals if vtable entry oh boy, if vtable entry function index is not invalid index and functions equals that, expects destructor. Dot is dtor. Let's rename this to is dtor. Or we say if else if not is dtor and vtable equals invalid index. Then we do also pushback. Oh boy, this is so confusing. I think this is wrong. If it looks too complex, it's most likely wrong. Yeah. It looks too complicated. Let's add some parentheses here, which hopefully makes it a bit easier to look at. Well, marginally. Oh boy. So basically we want to get destructors in line so that but then we have problems elsewhere. Yeah, I think this won't work here. This is garbage. Okay, it's already wrong because it never gets a destructor in there anyway. No, okay. I think it's wrong. How do we do it? Oh boy. Push back. People ask under the videos if this is helpful for the game or what does it do? Well, if you ask this question, then this is not for you. Yeah. There's no point in explaining this because either you understand or you don't. That's it. Oh boy. That's oh boy, I don't know how to implement this. The problem is we could do the search by name, but that won't work for the pure virtual functions because they don't have a name to begin with, right? So that's a problem. We need to get those overlaps across the hierarchy, but how do we do it? Oh boy. So we have a destructor. Okay, let's think. Well, it needs to be something in this direction. So, okay, let's say if it's empty, it's a first entry. If it's empty, then then we simply say if it's empty, we put this here. If it's empty. Yeah. We need to base class. Maybe we can say, maybe we say int detour left, the destructor left. It's initialized with 2. Detour left 2. Because we can have 2 at max, right? Okay. Then here we say detour left. Then here we say, maybe it should be detour left. Let's do detour left. Okay. Detour left. Okay. Then here we say detour left equals 2. Actually, detour left. Shit. It's extremely upsetting. Upsetting. I mean, a destructor has it has the destructor will have fucking the slot thing is so shit. So shit. Okay, how about we say detail. So int detour left is 2. And then we would pass it here. Does that make sense? Detour left. So and here base class, we would create a new detour left base detour left, and we also set it to 2, and then here we pass this base, and then here detour left par. Maybe we need a function here inside the vtable. Int count with detours const int count without detours. And I hope that this will be useful for something. I'm really desperate, yeah. Vtable. Still size T. So count with detours, count without detours. And then we do oh, well, the problem is we need to pass const functions maybe pass. we have a span here? No. Oh, not a big deal. Let's do std vector. Oh, we don't have function yet. Okay, let's forward declare struct function namespace enum variable base class vtable entry vtable class function instruction function variant function header file source file header file source file oh boy. Okay, count with detours. I don't think we can actually pass vector functions. We would have to pass. Bah. Do we have span here or not? Span. I think we need a span. To make. We don't have a span. Can we get it? We need a span. Let's get this one here. Span. Span. Populate. Oh, we have span here already. Oh. Span. TCB span. Includes TCB span. Okay, it's there. So I would say we do TCB span functions. There we go. Okay. And then here we would say return, no, for functions. Wait, is this correct? Not sure. Maybe. No. What is the problem here? It's complaining about something. Stop debugging. Declaration is incompatible. Error type. Oh, function. Function. There we go. Okay. Const. If function dot function dot okay, that's wrong. What am I doing here? Entries. There we go. Vtable entry. Okay, let's try again. Vtable entry. Const. Vtable entry. Looking forward to the day when I'm healthy again. Whenever there will be. Anytime. Oh boy. Vtable entry. Vtable entry. Dot function index. So we say if function index, wait, we need a size t here, size t I return I. Let's call it count. It's a better name. Count. We start with 0. Count. We remove this here. So if function index is invalid index, then wait, let's say here if it's not invalid index, then we do something, and here we do a plus plus count. And then we say if actually count with detours. What am I doing here? Count with detours. I think this goes in here. Count with detours is simply return entries, no? Return entries dot size. Basically everything. Yeah. Okay, let's just call it count. Count. There we go. Count without detours. Okay, count without detours. So we have count, and then we say if functions vtable entry function index dot is detour here. Okay, if it's detour, then we say continue. Yeah, I think that's it. Okay. I'm not yet entirely sure how this function will help us, but it seems reasonable that we have a function that can makes a count of the vtable entries without detours. Yeah. Okay. Now let's get back to this mess here. Okay, so basically here I would say if base detour left is 0, then base vtable then here we do get count without detours. Does that make sense? Functions. Does that make sense? If base detour left is 0, I'm not sure. Okay, let me put an update here. I have great difficulties overlapping virtual functions between class hierarchies. Yeah. Shit. So it's hard to implement, but even if we implement it, I'm not sure if it will be correct. Likely not. It's ridiculous how complex this bullshit is. Okay, so basically, if we override the virtual functions of one base class, and we should ignore the virtual functions of the other base class. That's the idea here, right? So we have two destructors per we have two virtual destructors per all base classes on one level, right? Actually, it's not just man. How about we need to simplify this logic. kind of like crazy counters. Maybe we need to. I mean, we can see what we have, what is inside, what we have already collected. Oh. My gosh, eh. This is so hard. This is really hard. Okay. So, let's say we have vtable entry, vtable, 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 vtable. Oh. I don't know how to do it. Okay. Maybe we need to flatten. Maybe we need to flatten the vtables first. Instead, yeah, I don't know. Yeah, maybe we need a different approach as to how we collect this. Instead of, maybe we don't do recursive functions. Or, oh man. That is so much. I mean, we walk the hierarchy correctly, I think. But the problem is with the virtual function. That's a problem. That's a problem. It is a problem. The problem is Even if I commit to some implementation, there's no telling that this will be correct. Like, I could make an implementation and it's totally different the way we need it. Hey, this is so hard. It's unbelievable. It's unbelievable. This problem is so hard because I don't even know the rules. That's one of the problems. I don't know the rules. Pfft, that's some bullshit. Also, I suspect that there's a mistake here because if we have multiple base classes beginning from another multiple base classes, then it would start index vtable entry index. Fuck me, eh? This is so hard. Poor. Tja. I don't have a good idea. This is hard. think I can think about this for 2 more years and I won't be able to figure this out. The problem is, I mean, obviously this whole code is wrong. It's very wrong now. Okay, let's get it back to something simpler. That's let's get it back to something simpler. Like what we had before. There we go. There we go. Good, so this was what we had before. All right. Yeah. So there are two problems here. There's a problem with the destructor, and there's also a problem. Wait, is there another problem? Let's see. Oh, base vtable entry index. Base. Actually. Base. I'm confused. If we have a 3-level hierarchy, then a 3-level hierarchy. Boy. vtable. I think we need to solve one problem at a time. I don't know how to do it. Um. Fuck. I don't know how to do it. This is so hard, this problem. It really is hard. My brain is not smart enough for this bullshit. Ugh. I don't know how to do it. It's so hard. It's impossible. It's not impossible. But it seems it's impossible. Because it's so hard. My gosh. Okay. So the way I think it should work is that when there is a the topmost we overwrite. Fuck. We overwrite. I don't know what to say. if it wasn't for the pure virtuals, then we could just overlap those functions by their name, right? Fair enough. But we can't because of the pure virtual, which doesn't have a name. Doesn't have a name. Damn it. Oh man. I don't know how to do it. Yeah. Okay, so we go into all childs. Vtable index. Maybe we should. Maybe we should just count things. Maybe we just count. Yeah, that's just stupid counting. Maybe we do that. Yeah. Yeah, maybe. Basically, I want to have an algorithm that is kind of easy to follow. What I'm here, I'm tempting is getting too complicated. Maybe we just go through all the base classes and then we just count. We count, but then, I mean, we kind of count already here. Here. Okay, but this is wrong here. I think this is wrong. Yeah. This is wrong. Okay, so if we count up, we go through all the classes and then we count up. Okay. Yeah. Okay, vtable. How about we say here vtable entry index. So we could have index t current maybe we say counter. Then here we say index t counter is 0, starts at 0. And we pass a counter here. And then index t counter. And so counter. And then we say if we say for then we don't do this base class, base counter. So we count. We have base vtable index. We don't do this. We pass this. Actually, it's okay. Let's do a counter approach. It's probably stupid, but I just would like to implement it. I don't care about performance. So we say for vtable entry, and then we say here plus plus counter. And then we say if plus plus counter equals vtable entry index, then we have found our target, right? But that's wrong, isn't it? Because now it only will find ugh. Yeah, that's stupid. That doesn't work. Oh boy. Counter. I have no idea how to do it. I don't know it. Psst. I don't know. I don't know how to do it. It's so hard. It is just, it's impossible. For me at least. I don't know how to do it. There is no easy way to implement this thing. I'm not even sure if this is correct. Like, let's say base table entry index. No. The thing is, all leaves need to be treated separately, but base but they are. I think this is actually correct, the way I pass I pass this index here. I think that's correct. But it's not correct in regards to the virtual destructors. We need to think how we deal with the virtual destructors. That is a mystery, it's for me. The virtual destructor. It needs to... Yeah, virtual destructor. Virtual destructor. Virtual destructor. Okay, how do we exclude the virtual table? If a virtual table is missing on one level, on one base class level, then how do we deal with it? We cannot, because what we have seen is that we overlap virtual destructors with something that is not a destructor, right? Because then on one base class level, the destructor is not virtual. It's not virtual. Oh man. Maybe we need to I have an idea, maybe. Counter Let's remove the counter again. Really experimenting here. So how about here we say I think what we need is a function that can tell us bool is virtual destructor. Destructor is, and then we pass this one here, const. I think we can make this static. Is virtual destructor, and then we would say return this not empty, and actually this needs to be not static. and out vtable entries 0 dot function index is not invalid index, and functions this index dot is ctor or dtor. So then we have a function that can tell us if it is a virtual destructor or not. I don't know how to use it yet though. The problem is I don't know. Shit, this is hard. This is so fucking hard. Okay. I think I'll take a break here. I don't know. I'm not going anywhere right now. I think the more I think about it, I probably get some ideas, but even if I implement what I think it could be, there's no telling that this will be correct then. It might be still totally wrong. It likely will be totally wrong. Well, wrong in some cases, in some rare cases, yeah. Well, in 50% of cases, I don't know. Shit. There's probably some way to implement it with a really good success rate. I think this is where we need to get. And then once we have it 90% correct, then figure out the edge cases and then try to figure and fix that, maybe. Yeah, this is how I picture this right now. Yeah. Okay, I think I will end it here. Yeah. Yeah, I wish you a great day or night. Until next time, goodbye.